can prepare it. We talked about their properties, such as like physical properties, boiling properties, such as, right? What else we did? Then we prepared something, then we reacted it with something else to prepare something else, like chemical reaction part. Or
Sir.
not? So we are going to follow a similar trend here. So let's start with our today's chapter, which is amines. Okay. So what are amines? So first of all, we should know what are amines. Amines are regarded as alkyl or aryl derivatives of ammonia. What is ammonia? Ammonia is your NH3. If you are removing one or more than one hydrogen and producing a derivative which is containing a R group, then we will call it amine. This is ammonia. Okay. If you
Yes,
are
sir.
removing and replacing a one hydrogen from ammonia and putting a R into it, then you will call it, you have produced an alkyl amine. Is it not?
Yes,
So
sir.
we have different sort of alkyl amines on the basis of like how many hydrogens you have replaced. So if you are removing one hydrogen, you will call it 1 degree amine. If you are doing 2 degree amine. If you are doing 3 degree amine. Okay.
Yes, sir.
Amines are amines are obtained by replacement of one or more hydrogen atom by alkyl or aryl group. Like ammonia, the amine atom has non-bonded electron pair, making it both base and as well as nucleophile. What do you mean by this statement? In your ammonia, we have a lone pair, and the rest part is also having the respective lone pair. So, what is a nucleophile and base? A nucleophile or a base is something which has electron density to donate and participate in a reaction. So in all the four cases, the lone pair is still intact. So you can say they all can act as a nucleophile as well as a base depending on the condition where we are using them. Okay.
Yes, sir.
So what we can say, amines can act as both nucleophile and base. Okay. Now, the chemistry of amine is determined by non-bonding electron pair on the nitrogen atom. The chemistry, the chemical reaction that you are going to observe while dealing with amine is entirely dependent on what? The lone pair which is present on your nitrogen atom. Dominated. Okay, so if you are seeing this, suppose here we have 3 degree amine because all the hydrogens are replaced by R. So if you are using it in presence of an acid, what it will do? It will abstract a proton and convert it into a conjugate base and itself a conjugate acid, right? Also, it can act as a nucleophile if the conditions are favoring the substitution or nucleophilic attack or electrophilic, basically nucleophilic attack, then it can also act as a nucleophile. If in a reaction you have acid, it will react as a base. Oh, sorry. I haven't turned on my video. I would request you to please turn on your webcam as well so we can interact better. Okay, please turn on. Am I audible? Ali, am I audible?
Yes, sir.
Please turn on your webcam. Okay. So what I was telling about your amine or amine 1 degree, 2 degree, 3 degree amine can act as a nucleophile as well as a base depending on the condition. If in your reaction mixture you are providing a acid, acid's main purpose is to donate H positive, and then your amine can act as a base and abstract that acid. But if your conditions are electrophilic, then it can also attack as a nucleophile, initiating some substitution or addition reactions. So your amine are very important because they can act proficiently in both ways. If you want him to behave as a nucleophile, it can do that. If you want him to behave as a base, it can also do that. So it is important. Okay.
Yes, sir.
Now, how can you classify amines? The classification of amine is based on three categories: either 1 degree, 2 degree, 3 degree. Yeah. On the basis of number of hydrogen replaced. If you are replacing one hydrogen, 1 degree, two hydrogen, 2 degree, three hydrogen, 3 degree, replacing. On the basis of aliphatic and aromatic. If you are having an amine group in a chain, you will call it aliphatic. If you are having your amine group in a benzene-like structure, then you will call it aromatic. Right? You can differentiate on the basis of that as well.
Yes, sir.
What else? You can differentiate on the basis of simple and mixed amines. So let us talk about this one, like how we can say something is a simple amine and something is not. Just give me a second. Suppose I am replacing two hydrogens by two methane. Now, the R group is what here? R group is methane, and both the R are same. This is methane, and the other one is also methane. So we will call it simple when you are replacing same group.
Yes,
Okay.
sir.
But if you are doing the same thing, but now you are using different substituents. Suppose you are using C2H5, then you will call it mixed.
Yes, sir.
Is it making sense? Okay.
Sir.
Now, let us talk a little bit about the nomenclature of amine as well, because here we have different rules to name different degree of amine. So if you're talking about primary amine, which is 1 degree amine, so how you can name it? So first of all, you should be able to understand or determine whether a amine is 1 degree, 2 degree, or 3 degree. So if you have to see it simply, then you can say if in a amine you are seeing NH2, then it is 1 degree amine. Why? Because only one hydrogen is replaced. So this is 1 degree amine or not?
Sir.
Hmm. The IUPAC name is alkane amines. If you have to name it as per IUPAC, then you will call it alkane amines. I am going to take some little examples so you can have a better idea. And what about the common name? If you have to name it like journal common name, then you can use alkyl amine. So let us see some examples. How many carbons are you seeing here?
3.
So you will call it as per IUPAC propane 1 amine. Simple.
Sir.
If you have to use common name, you can say N-propylamine. What about the next one? If you are doing the numbering, you are observing that on the second position you have a amine group. So you will call it propane 2-amine. Or for a common name, you can say isopropylamine, because this thing is a isopropyl kind of side group.
Sir.
Now, what about the secondary amines? If you are observing a secondary amines, then the IUPAC rules are different, because here, first of all, you know how to identify a 2 degree amine, because from ammonia, where we had three hydrogens, the two hydrogens are replaced by R group. So we will call it 2 degree amine or not.
Sir.
So now if you are supposed to answer or name these sort of structures or these sort of compounds where you are observing 2 degree amine, so you have to follow this rule: N alkyl alkane amines. So what do we mean by this? So let us try to understand it. Suppose to this nitrogen, we have two different alkyl chains which are connected to it or not. We have a
Yes, sir.
propyl chain. This is 7. And we have the other one is
Methane.
methyl chain, right? Methane. You are correct.
Sir.
So now, if you remember the IUPAC rules, we are supposed to make only one chain as our main chain. The rest are going to be considered as side group. or branch, right? So
Sir.
out of these two, which one is the longer chain?
Methyl.
Try to think about it carefully. Which one is longer chain? Longer. You have two chains.
C3H7.
You have propyl and you have methyl. If you are talking in terms of number of carbons, then you can say in propane we have 3 carbons, so the chain is longer.
Yes, sir.
But in methane only one. So if you have a choice to make one chain out of these two, your main chain, which one would you prefer to make?
Propyl.
Propane, right?
It's
So
propyl. Propane.
if we are using any chain as our main chain, then we are not going to use this "yle" term. The methyl, propyl, ethyl, this "yle" is going to be used only when you are considering a side chain. Okay. So
Sir.
how you can answer it? N-alkyl, the smaller chain, the shorter chain is N-methyl. The main chain is what? Your propane. Okay.
Yes, sir.
So you will name it N-methyl propane amine. This is IUPAC name. And if
Yes,
you have to
sir.
go by the common name, you can use methyl propyl amine. What about the next one? Here, both the substituents are same. So you can make either one of them as your main chain and either one of them as your side chain. So you will simply go N-methyl methane amine. Right?
Yes, sir.
Simple.
Yes, sir.
Now, if you are seeing something like this in your compound, then you will call it methylene in common nomenclature. Not IUPAC, common. Now let us talk about the tertiary one. Tertiary amines, how you can identify tertiary amines? If you are replacing all the hydrogens, then you can say it is a tertiary amine. Now the question is, to this nitrogen, we are going to have 3 different alkyl chains, and we can only make one alkyl chain as our main chain. So the respective two, the corresponding to one will be automatically considered as side chain. So if they are side chain, we are going to use that "yle" term, and for our main chain, we are going to use our propane term, like ane term, right?
Yes, sir.
So let us take this example. If you are seeing this one, where the R group is same, methyl, methane, right? Only one carbon. So it does not matter which chain or which carbon atom or which carbon chain you are going to make as your primary chain, or which carbon atom chain you are going to make as your side chain, because all of them are same. So how you are going to answer it? The general term is NN dialkylamines. NN suggests the position, alkyl suggests the substituents, the side chains, and this alkane suggests the main chain, right?
Yes,
So
sir.
let us see. Let us see. So how you can say it? N comma N dimethyl, N comma N dimethyl methanamine, and the common name is trimethylamine. Let us take another example. This chain is methyl, this chain is ethyl, this chain is propyl. Out of these three, which one you are going to choose as your main chain? Which one is the longest one?
Propyl.
Propyl.
Propane.
So the rest are going to be considered as side chains. So you
Sir.
are going to say N ethyl, N methyl. These are your side chains, so you are going to mention them as N ethyl and methyl. And the main chain is propane, so propane 1-amine,
Sir,
right?
sir, out of the side chains, the longest one will come in front.
No, no, no.
Like,
For the side chains, you will use your nomenclature, like the alphabetical terms, like which one is coming first in alphabetical order,
okay, sir.
right? Is it making sense?
Sir.
Okay. So now let us try to answer some aromatic amines, like how you are going to answer name your aromatic amines. So let us see about it. Mhm. Okay. I hope you remember what we call this compound. Benzene with an NH2. It is
Uh,
aniline,
Aniline, yes.
or you can call it benzenamine as well. So aromatic amines are named as so let us talk about aromatic amines. These are named as derivatives of simplest aromatic amines. Sorry. The simplest aromatic amine of benzene is aniline. In IUPAC, the simplest aromatic amine is benzenamine. So aniline is a common name. If you are asked what about the IUPAC name, what about the name as per IUPAC, then you will call it benzenamine. benzenamine. But for generally, in most of the books, you are going to see it as aniline because aniline is a common name, right?
Yes, sir.
So let us see this one. If you are using a methyl group, methyl chain, oh sorry, methyl side group, and this is two amine side group, then what you are going to observe, let us talk about it. The name for this compound could be orthotolidine, which is common name. Why we are using orthotolidine? Because we have a toluene sort of resemblance here and also aniline. So as common naming, we can use O-tolidine. But if you have to name it as per IUPAC, how you're going to mention it? Out of CH3 and NH2, which one is having higher priority? Aniline, because NH2 is, if you have to choose out of these two, NH2 will be having more priority or not.
Yes, sir.
So your CH3 will be considered as side chain or not.
Yes, sir.
So at two position, what we have? 2-methyl aniline. This is again a common name. Both of them are common name. I have mentioned it over here. Common name. But what about IUPAC naming? As per IUPAC, we call it benzenamine. Okay, so if you have to go through IUPAC, we'll call 2-methyl benzenamine. Is it simple or tough?
Yes, sir. Simple.
Okay, now these are some other examples of IUPAC. They are pretty simple, so I think you will be able to answer them. Let me take example of 2-degree amine, so we can understand. For 2-degree amines, what I told you, you have to consider one as side branch or side atom, and the rest, the bigger chain as your main chain. So here we have benzyl group. Both of them are phenyl. This is benzene, this is benzene. So you can go like N-phenyl benzenamine. This is IUPAC and this is diphenylamine common name. I hope this is simple. Just try to go through this page, and if you are having any sort of doubt, you can ask me. Then we will start with the preparation part.
Sir, in the
Mhm.
second one, how did we get 3,4 dimethyl aniline?
Mm, yeah.
In the second
Yes.
example. Yes.
Okay. So this is your mean, or one thing I should correct because this is going to be NS2, not NS3. I will correct it. If you go for the numbering, you are going to number it like this. At 3 position, we have methyl and 4 position as well methyl. So you will say 2,4 dimethyl aniline. This is a common name.
Yes, sir.
What about the IUPAC naming? You will use benzenamine.
Yes, sir.
3,4 dimethyl benzenamine.
Yes, sir.
Let me. You know why we use dimethyl? Because
Two,
methyl
two
groups are
methane,
there.
two methyl groups.
Anything else?
No, sir.
Okay, good. Okay. I have I missed the page here? Okay, what is happening here? Hmm. Right. So now let us do one question to like refresh your concept of how to calculate or how to determine how many isomers we are going to have by a simple chemical formula. I told you something about degree of unsaturation, where it is used. Hmm? Where does the use of degree of unsaturation you have observed?
Uh,
Mhm. I told you something about degree of unsaturation. Degree of unsaturation helps you to understand the complexity of your chemical formula. If the degree of unsaturation number is greater, then the combination of structures that you are going to get a simple chemical formula are very vast. But if the degree of unsaturation is zero, then the possibility of having double bond or a possibility of having a ring is zero. So you are going to get simple alkane chains. So degree of unsaturation helps us to determine whether our chemical formula is going to produce some very, very complex structures or some simpler ones. So at your level, most of your isomer questions are going to give you degree of unsaturation zero, so you don't have to worry about it. So it is one of your in-text question. They are asking, they have given you this simple chemical formula, molecular formula, and they are asking you how many isomers it could produce. So first step is you have to determine the degree of unsaturation. Degree of unsaturation is zero. So no rings or no double bonds are you are going to observe here, right? So what is the first step while you are dealing with the isomer question in amines? The thing is you have to start or go through the primary, secondary, and tertiary uh, sort of approach. See if you see this one, how many carbons do we have? Four. So if you have to make a combination where you are observing 1 degree amine, you have these combinations. Apart from it, you cannot have any other combination. Otherwise, you will going to produce a 2 degree amine. So you have four isomers from 1 degree amine, and the names are different. This is the indication that they are entirely or they are independent, or you can say they are new structures, not same. Okay, this
yes,
is your
sir.
secondary. Three possibilities. For tertiary, it is only having one possibility. Now I have mentioned something over here. नाम करते वक्त वर्ड रूट बदल जाता है तो चेन आइसोमर. If you are naming a compound and your word root is changing, that means your chain is changing. Suppose you started with the butane chain and the next isomer is giving you a propane chain. So here the chemical formula is still same because you have produced those structure from a single chemical formula. But the naming, at the time of naming, you are getting one compound as butane and other one as propane. So it is a example of chain isomer. But if only the position of a group is different. Suppose here the position of amine is at 1, here the position of amine is at 2. So these type of isomers are called position isomer. So in this question, they have also asked about the chain and position isomer. So you have to see the combination and you have to mention that these two are chain, these two are position. Is it making sense?
Yes, sir.
Okay. Now let us talk a little bit about the physical property of amines. Then we will go to our main agenda, which is the preparation of amines. Hmm. I think my students have messed with my PDF today. Pages are not wrong. Mm, 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 mm. Okay, I will rearrange it after the class. Mm. Physical properties of amines. Right, so let us talk about it. The physical state. How does amines will look like if you are seeing them in your lab? So the lower aliphatic amines are gases with fishy order. What do we mean by lower aliphatic amines? Can you tell me what are lower aliphatic amines?
Sir,
Hmm.
sir, I don't know what is lower in.
Less number of carbon, like small compound.
Yeah, so it is less number of aliphatic amines.
What are aliphatic? What does aliphatic means?
Uh,
Aliphatic means a chain, not a ring. If you have a chain, then it is aliphatic.
yes,
If
sir.
you have a ring sort of structure, you call it asymptotic.
It
So
is
if you have
branched.
lower branch sort of stuff. Lower aliphatic amines are gaseous with fishy odor. They are very smelly, you can say. Primary amines with three or more carbon atoms are liquid, and still higher ones are solid. So as you are increasing your number of carbon chain in your amines, you are going from gases to solid. Okay. As
Sir.
the compound become heavy, the physical state changes from gas to liquid, liquid to solid due to van der Waals forces of attraction. This one, the second one is very important, the boiling point. So 1 degree and 2 degree amines are capable of hydrogen bonding because they contain NH bond. So I told you in like the previous classes which or what atoms are capable of forming hydrogen bonds. How many atoms are able or you have seen making hydrogen bonds?
Uh,
Tell me.
uh, Alcohols. Uh,
Alcohol. No, I am asking about the atom. I told you na, chlorine, oxygen, and nitrogen, FON. These three atoms are capable of forming hydrogen bonds. Do you remember?
sir.
Hmm. So we have in amines. How does amines look like? This one. N is directly attached to hydrogen. So it is capable of forming hydrogen bonds.
Yes, sir.
So in 3 degree amines, what do we observe? In 3 degree amines, do we have a NH bond? No, because all
Sir.
the hydrogens are replaced by R. So because in 3 degree amine, there are no hydrogens that are capable of showing hydrogen bonding with our nitrogen, then we will say in 3 degree amines, we don't have any hydrogen bonding. And hydrogen bonding is responsible for a relatively higher boiling point because hydrogen bonding provides some stability. And if I have two options, suppose if I am heating something which do not have hydrogen bonding, and if I am heating something which has hydrogen bonding, out of these two species, which one is going to be more stable? The one with hydrogen bonding. And if I'm
Yes, sir.
trying to break bonds, which atom will lose their bonds or which atom will try to boil first? The one which is less stable. So if you have 1 degree, 2 degree, or 3 degree amine, which one will go first if you are boiling them?
1 degree.
Think again. Let me go back. You have these three compounds, right? 1 degree, 2 degree, and 3 degree. Here you are observing two hydrogen bonding, hydrogen
Sir,
bonding,
3
hydrogen
degree.
bonding.
3 degree.
One hydrogen bonding, no hydrogen bonding. Which one is more stable out of these three?
1 degree.
So it will have the highest boiling point,
Yes,
then
sir.
2 degree, and the least you are going to observe is for 3 degree amine,
Yes, sir.
right?
Yes.
Good. Okay. Now, they are not going to ask you just about amines now because this is your last chapter of organic chemistry. So now they are going to include all the concepts that we have studied so far. So I told you in the previous class while we were talking about ether that ether has similar boiling point to those of hydrocarbons. Why? Because although there is a presence of oxygen atom, but it is not able to show hydrogen bonding because in this compound, the oxygen is directly attached to a carbon, not a hydrogen. Okay.
Yes, sir.
So this will have less boiling point. The molecular mass, the molecular weight, if you look at the molecular weight is similar. So while we were dealing with our haloalkanes, what we used to say that if the molecular weight is high, the size of our atom, or we can say longer the chain, the more surface area, the more the van der Waals forces. So we can say the one with more van der Waals forces will have higher boiling point. But what about these kind of compounds? Here, the size is same, the length of the chain is same. So what is the contributing factor that is responsible for their very high, what you can say,
Boiling point.
no, no, very high difference is boiling point, right?
Sir.
If you look at it, the boiling point of your ether is very low, 38 degree only. But for amine, it is 78 degree. But for alcohol, it is even more, 118 degree. What is the reason? What is the driving force which is
Hydrogen
causing this
bonding.
hydrogen bonding? But in NH, we have hydrogen bonding. In OH, we also have hydrogen bonding. So why OH hydrogen bonding is making it more stable? What could be the reason? We are
Sir,
basically saying, Mhm.
because it is more like it makes a more stronger bond with hydrogen.
You are correct. The bond between OH is stronger than NH. The reason is oxygen is more electronegative. If you compare it with FH, then the FH bond is more, even more stronger than OH. I hope it is clear.
Yes, sir.
So what you can conclude here, that your acids will have the highest boiling point, then alcohols, then your amines. Okay.
Yes, sir.
Now let us see how you can prepare your amines. We have basically 6 methods, and they are pretty simple that you are going to understand it pretty easily. Okay. Let me see. I think I have done something. Which, what is it? What is it? Now, while we will be talking, like as we are going to talk about this preparation part, you are going to observe so many similar trends that we have studied so far. See, suppose let's take the first example. You have a nitro compound, NO2, and if you are adding a hydrogen or removing a oxygen, what we call that process?
Reduction.
So if you are reducing this NO2 group, then what you are going to get? NH3, NH2, which is an amine.
Yes, sir.
So how you can prepare amines? If you are starting with a nitro compound and you are reducing it by any reducing agent, we have studied about so many types of reducing agent, catalytic reduction, LiLH4 reduction, right? Other part
Sir.
as well. So if you are reducing it, you are converting it into an amine. But I told you something in the previous chapter that the strength of reducing agent depends how our compound, the desired compound, is going to look like. If we are reacting it with LiLH4, LiLH4 is a very highly reactive compound, highly reactive reducing agent. So if I'm using LiLH4, it won't be able to differentiate between the side groups. If it is seeing a carboxylic acid, it will reduce it. If it is seeing a ketone, it will also reduce it. If it is seeing a NO2 group, it will reduce it as well. So what if you only want to reduce your NO2 group only? So you will try to use a reducing agent which is very specific, which only interact with your NO2 group. So for only reducing NO2 group, which reagents you are going to use? These two. If you only want, suppose you have a carboxylic acid over here. You don't want to reduce this carboxylic acid into an alcohol. You only want to reduce this. So you will use these two reagents so you can specifically reduce your NO2 group, right? Otherwise, if you are going like H2PD, then this one will be reduced as well. If you are using LiLH4, then both of them will be reduced as well. I hope it is making sense.
Yes, sir.
So you can see it over here. Reduction with iron crab and hydrochloric acid. Iron crab is what? Your Fe plus HCl, or you can say tin plus HCl or iron plus HCl selectively reduces NO2 group only. Okay.
Yes, sir.
So if you have to reduce NO2 into NH2, then you will have to prefer this one because this is more selective, right?
Yes, sir.
What else do we have? Let's see. Let's see. The question should be how you are going to produce your nitro compound at the first place. How you are going to attach this NO2 group. And one more thing, it is not only limited to aromatic compounds. Okay, if you are having a aliphatic compound, suppose a chain with the NO2 group, you can reduce this as well into amine by the same method. Okay. So the question is how would you get this NO2 group at the first place? So we have studied some sort of methods here. If you are starting with haloalkane and you are reacting it with AgNO2, then you will observe a SN2 mechanism reaction as one so only single attack of NO2 at your respective site, and your I negative will be removed and you will get your NO2. And if you are reducing it, then you will get your ammonia. I hope it is making sense.
Yes, sir.
Okay, let us move ahead then. The first method is reduction of NO2. The second method is ammonolysis of amine with alkyl halide. So let us talk about it. You have you have ammonia. Ammonolysis means what? You are reacting your ammonia with alkyl halide in order to get amines, right? So I will show you the mechanism of this. Just give me one. See, what I just said, that you are starting with amine. This is your ammonia, sorry. And you are reacting it with alkyl halide.
Yes,
And
sir.
your main agenda is to prepare amines. So let us see how the mechanism is going to look like. See, the first step is going to be the nucleophilic attack of ammonia via SN2 mechanism. It will attack and it will remove this to SN2. So I told you something, if any compound or any atom is donating its own lone pair, then it will bear a positive charge. This Cl negative is removed as a leaving group. Now, this nitrogen is having a positive charge. It will try to neutralize this by sacrificing some side atom. So now this chlorine will come and take this hydrogen, and the bond which was present in hydrogen will be transferred over nitrogen to neutralize its positive charge. So what we can observe here, a formation of amine by elimination of HCl. Is it 1 degree, 2 degree, or 3 degree amine?
Uh, 1 degree.
Good. So you have prepared 1 degree amine. The reaction is not going to stop here because it is very highly reactive. Why? Because HC, this alkyl halide part is not limited. This alkyl halide part is not limited. So this amine which is prepared here is going to again attack at our alkyl halide. Why? Because now, try to think about it. Now this amine is even more electron rich because now we have a plus I effect. This lone pair which was present previously is now even more electron. So now it will again attack. How it is going to attack? Let me show you. Now, It will again attack same as the previous one. Okay, Cl negative is removed. This will abstract this hydrogen again to neutralize this. Now we have prepared what? A 2-degree amine.
Sir.
Now the reaction is not over yet. It again has a lone pair, and we have another HC hydrogen which it can sacrifice, right? So it will again attack. Again, this compound, this compound that we have made here is able to stabilize itself by sacrificing this hydrogen, which is going to be picked up by
Chlorine.
chlorine, right? So
Sir.
the electron pairs are going to go over our nitrogen to stabilize it, and it is going to look like this. HCl is removed. Now, what you have observed so far, if you are doing ammonolysis, then you are going to get a mixture of product. You are going to get 1 degree, 2 degree, and 3 degree as well, right? And it is not limited to 3 degree only, because this 3 degree amine can again attack and can form a quaternary ammonium salt. Now the question is, why after making this compound it is not going to proceed any further? Try to see it carefully and tell me why we have to stop our reaction at this quaternary ammonium salt.
Sir, because
Mhm. Your mic is off.
sir, sir, because H is not present.
Very good, because if H is not present, this chlorine won't be able to abstract anything, and this nitrogen compound won't be able to get stabilized. It will exist as a salt, and it will be precipitated at the bottom of your container. So after the formation of quaternary salt, this reaction won't go any further. So what is the drawback that you can see from this reaction? If you are trying to prepare your amines with the help of ammonolysis, what is the problem that you are going to face? You are going to see that you are getting mixture of products. Suppose if you only want 3 degree amine, if you only want 2 degree amine, and you are getting a mixture of all of them. So you have to separate them one by one, and it is going to be a hectic task. It will take some time. So this process is not preferred that much. So let us see what is happening here. Hmm. This is the thing that we have already discussed. The reaction mechanism I have showed you. In the next page, it is written in a concise way. Ammonolysis has a disadvantage of yielding a mixture of 1 degree, 2 degree, and 3 degree amines, and also quaternary ammonium salt. If you want to prepare only primary amine, then you have to take your ammonia as excess. Suppose you want to stop your reaction here. You want to make just 1 degree amine and you want your reaction to be stopped here. Then you will take ammonia as excess in very high amount so that it won't react to your alkyl halide again and again. So if you want to prepare primary amine only, then you will use your ammonia as excess. Otherwise, you are going to get the mixture where you will observe 1 degree, 2 degree plus 3 degree plus quaternary ammonium salt. Is it making sense?
Yes, sir.
Okay. Now, again, the third one is very simple. You have a nitrile you are going to do reduction. You are going to simply add CH2 group and you are going to remove the bonds. You are basically producing saturation from unsaturation, right? And for
Yes, sir.
this, you can use any type of reducing agent, catalytic reduction, LiLH4, or this NaHG ethanol. The main purpose is to make amine, right?
Yes, sir.
Nitriles on reduction with LiLH4 or catalytic hydrogenation produces primary amines. If you have a nitrile is CN, and if you are doing the reduction, then you are always going to receive a primary amine. Okay,
Yes, sir.
now let us talk about reduction with amides. What is a amide? Amide is something which look like this. Again, if you are removing this hydrogen and adding, sorry, if you are removing this oxygen and adding hydrogen, then we will call it reduction. And the important thing is you don't have to forget acidic workup. Then you will get your 1 degree amines. We are just doing reduction, simple reduction. Is it clear?
Yes, sir.
So how many ways we have talked about so far? First one was from NO2, if you are reducing NO2. Second one was ammonolysis, where you were reducing, where you were reacting your ammonia with alkyl halide. What was the third one? Tell me. What was the third method?
Uh, uh, reduction and
Reduction of what?
uh, reduction of reduction of hydrocarbon.
Reduction of nitriles. If you are reducing hydrocarbons, how? Well, like if you are only going to get something like alkyne to alkene, alkene to alkane, where are you going to produce this nitrogen atom? So you have to see a group where nitrogen atom is already present. Suppose while you were talking about NO2, NO2 had a nitrogen in it, right? While we are
Yes, sir.
talking about, see, here we have a nitrogen in NO2. Here we have a nitrogen in ammonia. Here we have a nitrogen in CN. Here we have a nitrogen in this amide. Okay, so we have to use something which already consists of a nitrogen. So the fifth and sixth methods are very important because they are named after someone. All the name reactions are important. This one is named after Hoffman. This one is named after Gabriel. Okay,
Sir.
so let us start it. Hoffman bromamide degradation reaction. This is a step down reaction. Suppose if you want to make a amine with a lesser number of carbon atom, then you will use this reaction, which is Hoffman bromamide degradation reaction. So what is happening here? The Hoffman rearrangement is a organic reaction of primary amide to form a primary amine with a one fewer carbon number atom. So here you are going to start with a amide, which is 1 degree amide, and you are going to produce a amine with having a one less number of carbon atom from its amide counterpart, right? And what you will observe that you are going to use Br2 plus 4 NaOH. In presence of Br2 and NaOH, you are going to produce 1 degree amine, and the side products are sodium carbonate, NaBr, and H2O. Where you will use this Hoffman bromamide degradation, where you have to produce a amine with one less number of carbon. This entire species will be removed and you will connect R and H2. Okay.
Sir.
Now, Gabriel phthalimide synthesis. If I have to choose one name reaction from this chapter preparation, then I will have to say that Gabriel is the most important one from your exam point of view. So you need to understand it. This method is used to prepare primary amines. If you want to prepare only primary amines, then you have to use or go by Gabriel method. So let us understand what is phthalimide. Phthalimide is this compound. If you are seeing something like this is a phthalimide. Okay.
Sir.
And if you are reacting it with a KOH in presence of alcohol, I told you something. If KOH is in aqueous medium, if KOH is in basic medium or alcoholic medium, then Which one is going to behave as nucleophile? Which one is going to behave as base?
Uh, Alcoholic KOH is going to act as nucleophile and aqueous KOH is going to act as base.
Ali, come on. It is written over here. We are using ethanol now, and I have mentioned base. So alcoholic KOH is considered as base, but aqueous as nucleophile. Okay, please remember this. I have written this statement so many times in the previous notes. So if we have a acidic hydrogen and if we are reacting it with a base, what is going to happen? Mhm.
SN2 reaction.
Ali, base. What is the main task of a base?
To extract H positive.
So we are not going to use SN2 and SN1. There we are going to use even elimination, right? Base prefer elimination. So in the reaction container, this is going to dissociate into something like this, and this is going to act as a base, and it will extract this proton. And these electrons are going to be transferred on nitrogen. So now you have a negative charge on nitrogen, and due to this K positive is going to surround it and make a salt. Okay.
Yes, sir.
Now we have an alkyl halide in our reaction, and this alkyl halide is 1 degree. This is 1 degree alkyl halide. So this nitrogen with a negative charge will attack here through SN2 mechanism, and it will remove this halide in the form of X negative. And we will have something, we call it an alkyl phthalimide. This is a phthalimide, but we have an R group rather than H group. We call it an alkyl phthalimide. Now, is this clear till this point?
Yes, sir.
Now, if you have this N-alkyl phthalimide and you are reacting it with aqueous NaOH, that two equivalent. So you will break this bond, and this NaO negative part and this H positive part, suppose here you are going to attach this O negative Na positive part, and this hydrogen will be attached to nitrogen, and the second hydrogen will attach to, we have two equivalent now,
Yes, sir.
NaO negative, H positive. So one hydrogen will go here, one hydrogen will go here. This Na positive, O negative will go here, and this Na positive, sorry, O negative, Na positive will go here. So after this, you are going to get these two compounds. This is a salt, and this is your 1 degree amine. Okay,
Yes, sir.
just try to see this reaction for a few minutes. And if you have any sort of doubt till here, please ask me. I will.
Sir, what was the name of the starting compound? Sir, your mic is off.
I was saying this compound, the initial one is called phthalimide because it is an amide basically because we have a carbonyl compound and this is attached to a nitrogen. And the entire thing is called phthalimide. The pH is silent, we call it phthalimide.
Okay, sir. Sir.
Okay. Now let us talk a little bit more about this Gabriel phthalimide synthesis. There are some notes that we need to remember. Gabriel synthesis yields only 1 degree amine. This thing will only give you 1 degree amine. 2 degree and 3 degree amines cannot be prepared by this because we are doing a SN2 sort of reaction. And this nucleophile is already bulky. So it will prefer a substrate which is not much bulky, a simple 1 degree substrate. If we are having a 2 degree or 3 degree substrate, then it won't be able to attack it from the backside and the reaction won't proceed. So in Gabriel phthalimide synthesis, the alkyl halide that you are using should be 1 degree. That's the only way you will be able to get a product which is 1 degree amine. One more thing, aromatic primary amines cannot be prepared by this method. So let us understand this. What is it mentioned? Suppose you have this. This is going to act as a nucleophile. So let me draw it over here. The last statement is saying basically that why we cannot make a product like this. I have a aromatic benzene, sorry, alkyl aromatic amine. Oh, sorry, aromatic halo benzene, chlorobenzene basically. So why we cannot make a substance like this? This will attack here and the chlorine will be removed. Why it is not possible? Because the first thing is we have to do SN2 reaction. And as benzene is a planar molecule, this is your benzene. And here you have a chlorine. This is in a plane. Inside a plane, if you are seeing a paper, a plane don't have a backside. If you are supposed to attack from backside, it don't have a backside. It is just a plane. So first thing is we don't have any backside. And the second of all, benzene is already electron rich and this nucleophile is already electron rich. So two negative charge species won't be able to attract each other. So it won't attack. And this bond is stronger. We have a partial double bond character here due to resonance. So this bond is also stronger. So it is more hard to break it. So we cannot make something like this. We cannot make something like this from our Gabriel phthalimide synthesis. You might be wondering if I do this reaction completely, I will get something like this. NH2. This is again 1 degree amine. This is again 1 degree amine, but it is aromatic. But from Gabriel phthalimide synthesis, we are only able to make aliphatic amines, aliphatic primary amines, not aromatic. So this reaction is very specific, very, very specific. You are only going to get 1 degree amine and that too aliphatic, not aromatic. Is it clear? They might ask you this question in your exam. So you should be able to answer it.
Sir.
We are done with our preparation part. Okay. So now let us talk about solubility. Solubility is somehow opposite of our boiling point. If your aliphatic amines are smaller, lower molar mass, then they are more soluble. As you are increasing the branching or if you are increasing the chain size, the solubility will decrease. As simple as that. Now, this is important again, basic character of amine. Right. Then we have structure, then boiling point. Yeah, this one is also important. Anyways. Okay, basic character of amine. I told you like in the starting part of our today's lecture that amines are capable of acting as a base as well as a nucleophile depending on the condition they are in. Okay, amines act as Lewis base due to the presence of lone pair on nitrogen atom. They are stronger bases than water and are therefore protonated by water in their aqueous solution. Can you justify this statement? Why amines are stronger bases if you compare them with H2O? Why uh, this is stronger base than H2O, despite the fact that oxygen has two lone pair and it has only one? Why this is still a stronger base? Think about it for a few minutes. Are you able to come up with something?
No, sir.
Why? We talked about in detail why something will be considered a stronger base in the first chapter itself. Suppose I am going to give you a hint. The answer is related to the electronegativity.
Oxygen is more electronegative than nitrogen.
Why? See, your answer is correct. You have to explain why.
Uh,
What is the main purpose of a base? What base wants to do?
uh, s- uh, Base wants to H positive ions.
How it is going to do that?
So uh, by the
By
lone
don
pair,
by donating its lone
by
pair
yeah, by donating its lone pair.
out of nitrogen and oxygen's lone pair. Which one will be more easily able to donate its lone pair?
Nitrogen,
Why? Because you
because
know
it is
that.
less electronegative.
So you were the one who came up with the answer, right?
Yes.
Now, I told you something as well, that strength is relative. If something is strong, it is always compared to something else. So if we are seeing both of them simultaneously, this amine and your H2O, then one of it is going to act as a base and the other one will automatically have to behave as an acid. One will abstract a proton and other one will have to give that proton. So because this is a stronger base, this will abstract the hydrogen from our H2O and it will convert it into OH negative and R NH3 positive. Is it making sense?
Yes, sir.
Now, this Kb is called basicity constant. And what does it signifies? It signifies how much base is produced in your reaction. What is the concentration of your OH negative? If your concentration of OH negative is more, if your OH negative is produced more easily, more rapidly, then you will say that Kb is high. Kb is what? Base dissociation constant, or you can say basicity constant. If more OH negative is getting produced, then you can say the Kb is more. If not, Kb is less. How you can determine this Kb? With the help of this simple formula. The concentration of product divided by concentration of reactant. Why we are not using H2O? Can you answer it? Because H2O is in liquid form and we consider it as unity. So we don't have to show H2O. Okay.
Sir.
Is it clear? Be honest.
Sir, if H2O was in the product, then
H2O wasn't the product. What do you mean by this?
uh, sir, we do not take H2O, right?
We are not going to take H2O for base dissociation constant formula.
Okay, sir. Even if it was in the product?
If it was in the product, then again we won't have to take it because H2O is not considered. It is considered as one. So if you are even mentioning it, ultimately you have to replace it by one. So it is not going to like cause any variation in your answer. So what do we know? Larger the value of Kb, Smaller the value of pKb, because Kb and pKb are inversely proportional.
Opposite. Yes.
Because pKb is nothing but minus log Kb. If pKb is higher, that means the basicity is low. Basicity is directly proportional to Kb. Try to see it for a few minutes, then we'll move ahead. The next, in the next topic, you are like the chances are 70 to 80% that you are going to get a question from there. So I will like give you a short trick so you can remember it for a longer period of time. See this one for now.
Answer.
Okay, so let us move ahead. Now we are going to relate the basicity of ammonia with alkylamines, then arylamines. So if you have to choose between these four, if you have to choose between these four, which one will you place at the, which one will you consider the strongest base and why? Is it going to be the simple ammonia? Is it going to be 1 degree, 2 degree, or 3 degree? Which one is going to act as the strongest base and why? Think about it. Again, you have to consider what is the main task of a base. What does base wants?
Sir, ammonia.
No. See, think about it. Think about it. You have to use plus I, inductive effect. You have to use the inductive effect factor. Suppose here we do not have any extra or side groups which are helping this nitrogen's electron density. It is not getting enhanced. But here we have one alkyl group which is using plus I effect to increase the electron density over nitrogen. Here we have 2 plus I. Here we have 3 plus I. So out of these 3 lone pairs or 4 lone pairs, which lone pair is having the highest electron density?
3 degree ammonia.
3 degree, I mean. So if the electron density is highest, then it will be more prone to react. Why? Because it has very high electron density. It wants to utilize it as soon as possible. So out of these four, which one is the strongest base and why?
3 degree amine because of plus I effect.
Uh,
The electron density will increase.
good. Okay, just give me a second. Okay. Right. So please read this one out, and I hope this is uh, clear. Like if you have a ammonia and alkylamine, which one is more basic? Alkylamine, because in ammonia we don't have any side group which is going to act as a plus I effect or
Yes,
show a
sir.
plus I effect.
Yes.
But this order that we have observed is only for gaseous state. while you are considering the ammonia and the respective amines in gaseous state, then you will say this order is correct. But what if, and from here they are going to ask question, but what if you have transferred this ammonia and amines into a aqueous solution? Initially, the previous order that we have observed was where the ammonia and their amines were in their gaseous state, isolated, like they were not interacting with anything. But now you have transferred this into an aqueous solution. Now, after you have transferred this into an aqueous solution, they are going to observe different type of interaction. They might observe hydrogen bonding from the solvent. They might observe some steric hindrance. They might observe some electronic factor. Like so many factors are going to play an important role. So the order of basicity in aqueous solution does not follow the expected trend. The expected trend is tertiary will be the strongest base, then secondary, then primary, then the simple ammonia. The trend gets altered. The actual trend of basic strength among 1 degree, 2 degree, 3 degree amine for methyl amines and ethyl amines are as follows. So you have to just remember SPT and STP. That's it. What do we mean by SPT? SPT means secondary, primary, tertiary. What do we mean by STP? Secondary, tertiary, primary. So if you have a amine which is methyl, like which is basically you can say, suppose this is your ammonia and you have removed one hydrogen with methane. This is 1 degree.
Sir.
We can call it primary.
Yes, sir.
Or if you have removed two hydrogens with methane, you will call it
2 degree.
secondary or 2 degree. And what if you have removed all the hydrogens with nitrogen, then you will call it
Tertiary.
tertiary or 3
3 degree.
degree. So if you have transferred this methylated ammonia in an aqueous solution, the basicity strength is going to follow the order SPT. That means first you will have to place secondary, then primary, then tertiary. This is your basic strength for methylamine. The secondary amine is going to be the strongest base, then primary, then tertiary. But what if you are replacing your hydrogen with ethyl? If you are replacing your hydrogen with ethyl, then you are going to face or observe this STP order, secondary, tertiary, and primary. The reason behind it is hydrogen bonding, steric effect, and plus effect. After including all of these factors, the experimental data showed these two order in aqueous solution. Is it making sense? And they are going to ask you this question in your exam. What is the basicity?
Sir, what is the difference between the first one and the second one?
See, in the first one, we are replacing our hydrogen with methane, methyl part. But in the second one, we are replacing it with ethyl.
Sir.
Let me show you.
Yes, sir. Yes, sir.
Is it clear?
Sir.
Sure.
Yes, sir.
In the second one, what you are observing is rather than this methyl, you are observing ethyl, 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 and ethyl. Okay.
Sir.
So the basicity strength or basicity order is decreasing from left to right. The strongest one is secondary. Okay.
Sir.
Now, again, a question for you. Now we discuss the strength of alkylamine with ammonia. Now let us do the same but with arylamine. Suppose you have this aniline. Aniline is amine as well or not? Because what we did basically, we had NH3 and we removed one hydrogen with this benzene ring. This is still ammonia and this is 1 degree ammonia or not? Sorry, 1 degree amine or not?
Yes,
Because we
sir.
have removed only one hydrogen. Now, if somebody asks you the strength of this aromatic amine and ammonia, which one would you say is stronger base?
Uh, Aromatic amine
Why?
because of plus I effect.
How it is emitting plus I effect? See, try to think about it carefully. This nitrogen's lone pair are participating in the ring. This is going to act as an electron donating group. So the electron density, this lone pair is not available. This electron pair is not available. And here this electron pair is available. So suppose you have money, right? You have invested your money in some stocks. This nitrogen had some lone pair on it, but it has invested into the benzene ring. But the other person, which is not investing, his money is safe in his locker room. So out of these two people, which one will be able to like use that money more easily?
The second.
Second one. So which one is going to act as a stronger base?
Uh, uh, Amine. No, ammonia,
Ammonia.
sorry.
Okay.
Yes, sir,
But
ammonia.
what if I am comparing now these two with uh, amine as well? Suppose now I have 1 degree amine, simple amine. So now out of these two, these three, which one is the strongest base?
1 degree amine.
Why?
Because it has the most
Electron rich
electron.
lone
Yeah,
pair.
it is more electron.
So I hope it is clear.
Yes,
This was about it. And yeah, this is how the resonance work in aniline. And it is same. The lone pair, the negative charge is again going to revolve only on ortho and para position. Right?
yes, sir.
Now, let us see. If you have an electron donating group, the basicity will increase. Why? Because your electron cloud will get even more rich. Right? If you have an electron donating group, if something is donating electron to a nitrogen, the nitrogen's lone pair will become even more electron rich and it will be more prone to attack. But if you have attached the electron withdrawing group, the basicity will decrease. Why? Because now the electron cloud, the lone pair which was present on nitrogen, are getting pulled by something else. So they are less available. So they will act as a weaker base. So do you know, like now you know the what is the role of electron donating group and what is the role of electron withdrawing group while you are talking about basicity.
Yes, sir.
So the last point, or sorry, let's let second last point is aromatic amines are less basic than aliphatic amines and ammonia. I have explained you the reason why it is. Because
Yes,
in
sir.
aromatic amines, the lone pair is invested in resonance.
Yes, sir. It is donating.
Effect of hybridization. Electrons are held more tightly by orbital with more s character. Suppose if you have a sp3 carbon, sp3 nitrogen, sp2 nitrogen, and sp nitrogen. Out of these three, this one will be able to donate its electron density more easily because of less electron negativity than sp2 than sp. Okay, let me take an example of it as well. Or we don't need it. Just leave it. The sp2, sp2, sp2. Okay.
Yes, sir.
Okay. I was hoping to finish this today, but hmm, let us do one or two lectures. Or how many pages are left? 8, 9, 10, 4, 5, 6. Okay. Now we are done with our preparation part. Now we are done with our property part. Now we will do what? We will react these amine with something else to prepare a new compound. Chemical reaction. Acylation or benzoylation. If if you have a 1 degree or 2 degree amine and you are reacting it with acid chloride, it will form 2 degree and 3 degree amides. The reaction is carried out in presence of pyridine, which serves to neutralize HCl formed in the reaction. I told you somewhere before as well, like what is the purpose of pyridine? To neutralize HCl. Okay, so let us see.
Yes, sir.
If you have 1 degree or 2 degree amines, this is a 2 degree or 1 degree amine. Tell me whether it is 1 degree or 2 degree.
2 degree.
And you are reacting it with acid
Uh,
chloride
acid chloride.
in presence of pyridine. What you are going to observe? This thing will attack here. It will do the reaction and it will remove it, and you will get this. This part will basically be attached here by the removal of this hydrogen. Okay.
Yes, sir.
So now what is important here? The importance is from a 2-degree amine, you got a 3-degree amide. Why we are calling it 3-degree? Because here we have replaced all the hydrogen,
Sir.
or not,
Yes, sir.
by the elimination of HCl.
Yes, sir.
And this HCl will be neutralized by this pyridine.
Sir.
The mechanism is as follows. This will attack here. The nitrogen, the oxygen will have a negative charge. Then this negative charge will be again pushed back into the bond, and this chlorine will be removed as a leaving group. Now this nitrogen will sacrifice this hydrogen and it will combine with this chlorine in form of HCl, and we will have our product. That's it.
Yes, sir.
Okay.
Yes, sir.
We can do this reaction by acid chloride as well as an anhydride. The same thing is going to happen. You will break this bond and you will attach this thing here. This hydrogen will remove and you will get your product. But with anhydride, the side product is not going to be HCl. It is going to be a carboxylic acid.
Yes, sir.
Okay. You
Sir,
can watch this again.
sir, the carboxylic acid will also be neutralized, right?
Carboxylic acid, no, it won't be neutralized. It
Okay,
do
sir.
not need to be neutralized. HCl is harmful. It is a gas, no? That's
Yes,
why
sir.
we need to neutralize it. Right?
Yes, sir.
Mm, let us see this one. Like, let me show you the mechanism of this as well, so you will have better idea. See, one more thing. I should tell you. If you are starting with 2-degree amine, you will get a 3-degree amide. If you are starting with 1-degree amine, oh sorry. If you are starting with a 1-degree amine, you will get a 2-degree. From 1 degree to 2 degree, from 2 degree to 3 degree.
Yes, sir.
Let us take an example. What is written over here? This is a 1 degree or 2 degree amine.
2 degree.
Aromatic or aliphatic?
Aliphatic.
Why? We have a benzene ring, aromatic. Aromatic amine, not aliphatic. Suppose if
Sir.
you had this thing, suppose something like this, then it is a aliphatic, but it is aromatic.
Yes, sir.
Hmm. Now we are going to react it with an anhydride. Suppose which anhydride should we take? This one. The first step is the nucleophilic attack over this carbon, and it will go up. I am using the benzene as pH, showing the benzene as pH. Positive charge H C O negative, because the single bond will be transferred over oxygen, and we have CH3 like this. We have our O C double bond O CH3. Right now, this density will go back, and we will remove this pH and pH positive H C H C double bond O negative. Now this O negative will abstract this proton to neutralize the positive charge. pH and pH lone pair. Am I missing something? I think I'm missing something. What is it? Ah, this part is going to impact this plus pH C double bond O OH. Please see it is the mechanism clear what is happening. And if you have any doubt, please ask me, okay? Any arrow that you are not able to understand why this arrow is like this, please ask me.
Yes, sir. Clear.
Sure.
Yes, sir.
Okay, so I think this is it for today's class. In the next class, we will complete this chapter and we will start a new one as well.
Okay, sir.
Alright.
Yes, sir.
So I am going to share this updated PDF with you and please revise and I will
Sir,
mark some homework. Ask me.
which chapter will start next?
We have completed how many chapters till now?
Uh,
I think we did solution
Solutions,
and what else?
coordination, chemistry,
Or
haloalkanes.
okay. I think our
Uh,
second book is going to be completed after this chapter.
okay, sir.
Uh, Is it? Have we done biomolecules?
Yes, sir.
So after this chapter, our second book will be completed, and we have done say like 2 or 3 chapters from our first book.
Yes, sir.
Have we done electrochemistry or chemical bonding, chemical
No,
kinetics? I
sir.
mean,
No, sir.
so we shall start electrochemistry next.
Okay, sir.
Okay.
Yes, sir.
Uh, how many chapters do we have now? Electrochemistry, chemical kinetics, D and F block, 3 chapters.
Okay, sir.
Okay, so that's it for today's class. We will meet in the next one. Bye.
Bye, sir. Thank you, sir.